So today we continue learn chapter 9, section 5. This called construction regular polygons. So, at the beginning I already emphasized geometry is not training your logic thinking, but also use your hand to build figures. Now let's say and shapes. So here in this section we try to build a square, then build a regular hexagon, then build a regular octagon. Now how to do this? So how to build a square? Now let me ask a question. Sorry, do you have any idea to build a square?
Not sure.
Not sure. And Lucy, do you have any idea?
Are you allowed to use a protractor?
You can use two tools. One is compass and straight edge. This is the two.
Oh,
You cannot use protractor. You can only use compass and straight edge. Okay. Say this one's a square, right? Suppose this one's A, B, C, D. So we try to build this square, right? You can say to build a square, definitely we need to start from the one edge, one side. Let's first, we can use a straight edge. Just draw a line segment. Suppose we call this one, it's A prime, B prime. Okay. Then you can use compass to measure the length of AB to make the A prime, B prime equals AB. You start from here, you measure this, then you draw this, then the intersection point, this one we will call B prime. By this way, you make the A prime, B prime equals AB. Now, the key point is how we can find these two vertices, C and D. You know the BC is perpendicular to AB, right? And AD also perpendicular to AB. So that means we need to build a perpendicular line perpendicular to A prime, B prime, but also pass through B prime and A prime. So how we can do that? We already learned that. Let's say, Jerry, do you still remember how we can build a line perpendicular to another line?
I kind of forget.
Yeah, see here we try to build a line perpendicular to A prime, B prime, but pass through B prime. This is what we try to do. And let's see, who remember this? E, do you remember this?
I think you can. Align the. I think you can align the compass from point A prime to B prime, and then draw an arc from B to draw an arc from B to to wherever until it meets at least the center of the line, and then do the same with B and find the point, and after that you can draw a line from the point to the line, and you have perpendicular lines.
Yeah, that's right. So the idea is this. First, you need to make this point, it's a middle point of line segment. So that means you can use a compass to build another, you can draw, let me change the line here. You can draw another line segment start from here. Suppose here you have this point that equals A double prime, okay? This A double prime B prime equals A prime B prime, okay? Here what I draw here looks not good. It looks not not equal. So now let's make this one, anyway, make this one go to here. So first you need to draw a line segment, okay? Suppose this one, that's A prime B prime. Then start from here, then you continue. So let's suppose here that's A, okay? Then suppose here that's B. So then you build another line segment A prime B. This one equals this, right? You can use compass, right? Then you can measure, use this point, measure length of AB. Then you go here, you draw a little arc. Then you extend this line. Then you have an intersection point here, right? By this way, AB will equals A prime B. Now you still use compass. Make the compass a little bit open, a little bit bigger than the line segment AB. You can draw like this. Draw a little arc here. Draw a little arc here. Then you use this point as a central point, but keep that openness. Draw another arc here. Draw another arc here, right? But this way you can connect this, right? Make this one is perpendicular to AB. Then you can extend this one, make this one longer, right? Then you can use your compass, use B as a central point, then length of AB as a radius to find where is the point C. Okay, suppose you found that point C is here. Then you can do the same thing. You extended this line segment, go to left side, use A as a central point. Extended this one, suppose here. Suppose this point, that's B prime. Then A, that will be middle point. Then you use the same way, use B prime as central. Then you draw a little arc, suppose that one here. But that one should be a little bit bigger than length B prime A. Then you draw that one, suppose here. Then use B as center, then draw another little arc here. Then you connect this point here. Then you got this one will perpendicular to B prime, and A is the middle point. Then you use A as center, use length of AB as radius, find point D. Okay, suppose then you found the point D, it's here. Now you just connect CD. Okay, by this way you get this shape that's ABCD, it's a square. Because when we, in this process, when we build this one, AB equals BC, and AB also equals CD. And also, we also get this angle equals 90 degrees, this one equals 90 degrees. So that means the sum of these two angles also equals 180 degrees, and this line parallel with this line. So therefore, this angle also 90 degrees, this also 90 degrees, right? So if you already know how to build a line, suppose this one's M, this one's N, perpendicular to this line AB and pass through B and A, then this will be much easier, right? Because you already know how to build this. But here I already show you how we can build this line perpendicular to AB and pass B, and also build a line perpendicular to AB and pass through A. Then if you already know that process, you don't need to repeat that. You just need to measure BC, that's equals AB. Okay, measure AD equals AB. Then you find the intersection point C and D. Then you connect CD. Here, then you got the square, right? So this one, it's easier. This is one way. Actually, there's another way. Is somebody have idea use a circle to build a square? Suppose we have a circle. Use a compass. You can build a circle, right? You use suppose this point as a center, then use this one as a radius, then you can build a circle, right? When you build a circle, the radius, you can extend this radius to intersect with this circle. Suppose at the beginning, you suppose you have OA, that's a radius. You use this one, build a circle. Then you extended AO, intersect with circle here. Suppose that's intercept with C, this AC. Now, here, we already have point AC. Can you find the point of B and D of the square? You see, to do that, it's very easy. Because O is a center of circle. Definitely O is the middle point of AC. Here, AC is a diameter. Then you can use a compass. Use A as a center point, and a length bigger than OA as a radius. You can build a line pass through A and intersect. You can get this, okay? You can get this, right? Because this we call this one, it's B and D. This BD is perpendicular to AC, but also bisector AC, right? Because O is middle point. To build this BD is very easy, right? You use A as a center, then you just draw like this, draw an arc, then use A as a center, also draw arc like here, then use C as a center, use the same length as a radius, then you draw another arc, little arc, then the intersection point of these two arcs will give you the 2 points. You connect these 2 points, maybe not exactly intersection on the circle, but when you extended these two this line segment intercept with this circle at B and D. Then you can think when you connect this A, you connect A, B, B, C, and C, D, and A, D. Now this A, B, C, D will be a square, right? Because you see here, then we'll get AC perpendicular with BD and also intercept each other, right? Because square, there are two diagonals perpendicular to each other and also bisect each other, right? Then by this way, you can say this triangle congruent with this triangle, so AB equals CD, and this one also congruent with these four triangles. Here, these four triangles are all congruent. So then all four sides also equal, right? This is another way to build the square. Use a circle actually is easier, right? When you build a circle, you have this center, you have a radius, right? Suppose this radius is OA, then you draw a circle. Then you extended AO to intercept with the circle at C. Actually, this A and C, it's two vertices of this square we try to build. Then you can build another line BD perpendicular to AC and pass through O. Suppose this BD intercept with this circle at B and D. Actually, this BD will be another diameter of this circle, but perpendicular to this diameter AC. Now, this 4-point ABCD, that's the vertices of this square, right? So this one is two ways for us to build a square. Now, second one, how to build a hexagon. Hexagon, have 6 sides. Now let me ask Diana, do you have any idea to build a hexagon?
Well, you would first have to create I guess the two sides, the two parallel sides first.
To build the two parallel sides, okay. So you mean this, okay? We just got this one side, okay. Then suppose this one. Now how this one parallel with this? Okay, give me a second. Suppose this one parallel with this. Now how you continue?
Both to be the same length.
Okay, you measure the same length. Suppose start from here. This one is A, this one is B. Now I make this one. Suppose that's see, this one it's D. This one it's E. Okay, then how continue? So suppose AB now equals ED. Okay, this one, if you do this, that's hard. Because say, yeah, you have these two sides, they are equal and parallel to each other. But you still need, say, you need to build this here two sides also equals this AB and ED. And at the beginning how you measure this distance. Make these two lines the distance what you need. They don't allow you use ruler, right? You can use that compass and straight edge. Let's say 3. Do you have any idea to do this? To build a hexagon?
I was thinking of doing a circle, but I'm not sure how.
Use a circle. You think use circle, but okay. Jerry, do you have an idea?
No, not really.
Not really. And Dylan, how about E? E, do you have an idea?
I have an idea to use a circle.
How to use a circle? Okay, suppose.
Can you draw a circle?
Okay, let's suppose I draw a circle here.
We can use the same similar method to how we drew the square with the circle, because I think I remember that if you draw the radius of the circle.
Okay, suppose yeah, we draw a radius of this circle. Suppose here, this one.
And that distance, the distance, measure it with your compass. And if you put it on A and then use draw marks or tiny arcs.
Okay.
For each.
You use A as a center.
Yes, and
use
draw arcs.
OA as a length.
Yes.
Then you draw. Suppose let's suppose that's here.
And keep drawing and use your new
use this one as a new center. Then draw another one. Okay.
And then that should be worth and when you connect it, it should be worth hexagon.
Why?
I think it's because when you make the hexagon into equilateral triangles, it's the same, it's just sectors instead of triangles.
Yeah. Yes, actually you're right. Very good idea. Very good. Exactly. If you use circle, just do like this way. It's very easy to build a hexagon. Then you just use radius. This one OA as a radius. Suppose you start from A, use OA as a radius, draw a little arc intersection with the circle. Suppose here that's B. Then you use B as a center. Use length of OA as a radius. Draw another little arc intersect with arc with the circle at C. Do this one. Suppose this one's D. This one, suppose that's E. This one, suppose that's F. Okay. Then you connect these points AB, BC, and CD, and DE, and EF, and AF. This one will give you a regular hexagon. You know why? Because, say, if you use this one connect, you got an OA, AB. If you also connect this OB, you can say this OAB will be a what kind of triangle? That will be a equilateral triangle, right? Because we use OA as a length, draw AB. So OA equals AB. And OB is also a radius. OB equals OA. So OAB is an equilateral triangle. Then similarly, OBC, OCD, ODE and OEF and OFA, all these 6 triangles are equilateral triangles. Then you can say this angle should equal 60 degrees. Then they separate this circle as 6 equal parts. So each angle equals 60 degrees. Then they make this, each angle will be 120 degrees, right? And each side all equal. So then this one's a regular hexagon. See, you can see here, use a circle to build the regular hexagon. It's very easy. Yeah, this is the best way. Do you think have other way? If we don't use circle, can we build a regular hexagon? If we don't use a circle as similar to the previous problem, we build a square. You can say first we also draw a line segment. Suppose this one's AB. Okay, let me move this one a little bit to the right side. We draw this AB. Okay, suppose this one is AB. Okay. Now, do you know how we can draw a equilateral triangle? Use this side as one side. You just use point A as a central point. Use length of AB as a radius. Then you draw a circle, draw a little arc. You don't need to draw a circle. Okay, suppose you draw here, right? Then you use the B as a central point. Then you draw another, still use AB as a radius, draw another arc. Okay, suppose you intercept here as O. Okay, then you connect OA and OB. This one will give you a equilateral triangle. You connect this one, this, right? By this way, we get a OAB. It's an equilateral triangle. Now we do the same thing. We use OB as a radius. We use O and B as a center. Then we can draw the little arc. Suppose use O as a center. We draw a little arc here. Okay. Yeah, we need to use. You can draw a little arc here. Then you use B as a center, still use OB as a radius, draw a little arc here. Then this intersection point will be the C, right? Because you connect here, you can connect to this one, then you get another equilateral triangle. Okay, this one will be C. Then you do this. Okay, then you get a regular hexagon. Because by this way, very easy, we build a equilateral triangle. Then we continue build another equal triangle. Then we got this point C. Then you do the same thing. Then you get this point, that will be D, right? Then you connect. No, we need to use line. You connect this point, you connect OD. This will be another equilateral triangle. This point will be C, will be D. Then you continue do this. Then you find that E and F, right? You continue do this. This will be, suppose that will be intersect here. This one will be suppose here. then you connect these 2 points. This will, suppose this one will give you point E. Okay, then when you connect OED will be a regular triangle. Then you start from here, then you draw another arc. Suppose that will be here. Then use this one, you suppose you draw here. Then you got this point, suppose that's called F. Okay, then you connect OF, EF, and AF. Okay, then you got this one, this regular hexagon, A, B, C, D, E, F. Definitely what I draw here is not so accurate because I don't have a compass here. So if you use compass, you can draw perfect hexagon here. Okay, so this way we start with one edge of this hexagon, then we build the other edges, right? We use equilateral triangle because it's very easy to build an equilateral triangle, right? Build an equilateral triangle is very easy. You have this set, then you just use this set as a radius. Use these 2 points as a center. Just draw a little arc. These 2 little arcs intersect at a point. That point will be the third vertex of this equilateral triangle, right? You will find these 2 points. One is here, another is here, right? If you try to build the hexagon, regular hexagon, use this one as the top side, you need to choose this point. That will be the center of this hexagon. If you try to build the hexagon, use AB as a base, the lowest side, then you choose the top intersection point, right? So here you just choose this one, then start from here, continue. You can build the other vertices of this hexagon. Okay, this is the 2 ways to build a regular hexagon. Now let's see third problem, to build a regular octagon. How to build a regular octagon? Octagon has 8 sides, right? So each angle of octagon equals how many degrees? Let me ask Lucy, do you know each interior angle of octagon equals?
It's 135.
135, correct. Very good. So do you have any idea to build a regular octagon?
Well, 135 is 90 plus 45, so I guess you could use that.
Yeah, you can use that. You can use that, but what is your plan? Say first we can draw any set. Suppose this one is one side of this octagon. Then because each angle equals 135 degrees, so that means we can draw a perpendicular line pass through this B. We can draw a perpendicular line here, perpendicular to B, AB. Okay, pass through B. We can draw this one, right? Now here you can extend it. You can extend it, this AB. Suppose go here. Now, how we can find a 45 degree? Sorry, do you have any idea? Suppose this one, if I mark here as A prime, okay? Suppose here it's like a C prime. Do you have a way to find to build an angle bisector of this angle, A prime, B, C prime. Can you build an angle bisector of angle A prime, B, C prime? Sorry, do you have any idea to do that?
I don't remember.
You don't remember? Okay. Let's see. Dylan, do you still remember? We actually will build this one before. This one is a very normal way. Just use a compass. Very easy. See, you just try to find a point, right? That's in the middle of these two edge. Okay, now let me ask E, do you have any idea?
Can we just bisect angle B or angle A prime B C prime?
Yes. Yeah, we try to build angle bisector of this angle.
Okay, so you can just draw like arc from with the center angle B, but draw it like a smaller arc. And after that, put your name your arc like DE perhaps.
So first, you need to use which point as a center to draw the arc?
Point B as the center, outwards towards A prime and C prime.
Yeah, so suppose we use this one draw here, right? You still use this same radius draw. Gotta suppose this point I just call this one A prime, this one just like call C prime. Okay. Then you use A prime and C prime as a center, right? You
yes,
draw. Then
you draw.
You can draw. You can make here does not matter. You can still keep use this length. Then you draw an arc here. Okay, suppose that's one here. Then you use a C as a center. Still use that one as a arc. Use this same length. Draw another arc here. Then you got an intersection point. Okay, this intersection point, if you connect this one, that will be bisect this angle. Suppose this point we called C. Because this angle will equals 45 degrees. You know how we can prove this? Because if you connect A prime, C, and this one, you can see here we got these two triangles, BC prime and BCA prime. These two triangles are congruent, right? Because see, we have this side equals this side shared, right? And this side also equals this side, right? So that's SSS, three pair of sides are equal. So then these two triangles are congruent. Congruent, that means the corresponding angles, they're equal. This angle is this angle corresponding because this side equals this side. So then each angle of here that's equals 45 degrees. Then 90 plus 45, this will be 135, right? So then after this, we got this line BC. Then we need to use the length of AB to measure BC, make the BC equals AB. Then this BC will be the second side of this octagon, right? Now you continue. after you got a BC, then you can draw like another line perpendicular to BC, right? You just repeat what we did here. Then you can find the next point. That one will be D. Then you keep doing it, because by this way we got each angle will equals 135 degrees. Then you keep doing it. I'll also make this side will equal this side. Keep doing it. Then you get your octagon, right? The next one say first we draw a perpendicular line of this BC. You can draw this perpendicular to this. Then you extended this one. You extended the BC, right? Then you build the angle bisector. You build the angle bisector here. Okay, the angle bisector suppose here. Then you measure BC also equals, suppose here that's CD. Okay, suppose that's CD, right? Then you start from D, repeat this process to build E. Okay, you still do this one perpendicular to CD, and make this one longer, extended this one, then find the angle bisector of this one, then measure CD equals, suppose this one is E. Okay, then you extended this one, still repeat this process. Okay, then you got another point that will be, say, draw another line perpendicular to this, then make this one longer. Okay, then find the angle bisector of this point. Suppose that intercept with here, then also make this, suppose that's EF equals DE, okay, because each side should equal, right? Then you can get this one's F. Then continue from here. Suppose then you can build that point, it's G. Okay, suppose that's G. Okay, here you can connect it FG. Okay, then you can build H. Suppose that one will be here. Then later you connect this. Okay, H. Now say A, B, C, D, E, F, G, H. That will be the regular octagon we built. Yeah, after you found BC, then after the other points, just repeat, simply repeat the previous work. So this is a one way, okay? We just start with the side. Do we have another way? Use a circle. Now let's say 3. Do you have any idea? We can use a circle to build a octagon.
I'm not sure, but maybe you could use like a similar method to the hexagon one.
Okay. And Jerry, do you have any idea?
Not really.
Not really. Lucy, do you have any idea?
No.
No. E.
So similar to the hexagon one, we see that I found something interesting, that because a hexagon has 6 sides, and the whole arc of the circle is 360 degrees, and if you divide 6 by 300, 360 degrees by 6, you get 60 degrees,
Yeah.
which is expected because it's the arc of one circle. So we can do the same and divide 360 by 8 in order to get 45 degrees for each. So therefore, now we can first draw a line as the diameter.
Okay.
And after that.
Okay, so that means first we have draw a diameter. Suppose this one is the center. Then we can draw a diameter. Suppose that start from here, pass through this O, intersect with, okay, the circle. Suppose this one we call the A, this one called the B. Okay.
And now we use the compass as the center for B, and use the length of A, and draw an arc above O.
So you use which point as center?
We'll use B as the center, and later we'll use A for the same for the other arc, and we use AB as the length.
Use AB as length. So you use this diameter as a length?
Yes, basically what we're doing is we're bisecting line AB.
Oh, okay. You just bisect AB, then you try to draw another line. They will perpendicular to AB and pass through the O. So something like this. Okay.
And therefore, we have now 4 sectors.
Yes.
With 90 degrees each.
Yeah,
now we can just use the same trick in order to bisect each of the circles, like the COAAOD, like those angles.
So
into 45 degrees.
Yeah, you try to bisect this angle, right? So
yes,
that means you try to
and then just connect the dots. Yes.
You try to get this, bisect this angle, and also extended this one, right? To this. Then you do exact same thing for this one, right?
Yes, and now we have 8 equal pieces.
Exactly. Yes. Exactly. So this one just first borrow the idea to build a square. Use a circle. Say when you use a center O as use this point as a center, use OA as a radius, you can draw this circle, right? Then you extended AO to B, like this circle intersect with the line at B. Then AB, that will be a diameter. Then through AB, we can build another diameter, CD, perpendicular to AB, pass through O. Then this ACBD, this 4 point, if you connect, that will be a square. That's just we build the square in the first problem. Now here, try to build an octagon that's 8 sides. You can just bisect this angle. Then you got suppose here, you got E, this one that will be F, this one that will be G, H. Now you connect these points, connect CE, AE, then AH, then DH, then DF, then BF, then BG, then CG. This one will give you a regular octagon. Okay, say use a circle to build also much easier, because it's very easy to use a circle to build a square. Then it's also very easy to separate, to find the angle bisector, right? After you got a square, then you get a 2 perpendicular diameter. Then you use a trick to build a bisector, angle bisector. You got this EF and GH. that will be another 4 point for this octagon. Then you just connect these 8 points. The figure, what do you get? That will be a regular octagon, right? Because for each this center angle, because 360 divided by 8, this one should equals 45 degrees, right? That's the reason first we build a square, then we use angle bisector separate these two right angle as 45, 45. Then this one will give us all the vertices of this octagon. Okay, so you can say this is a very smart way to build an octagon. So then we finished this section. Now let's go to next section. So here, that's summary. So that means we already finished this chapter. In this chapter, what do we learn? That's polygons, right? Polygon, that means all the sides are 9 segments and also closed, okay? It's closed shape. And all these points we call the vertices. And then each segment we call the side. And then the different, if they're not adjacent to each other, then the vertices connect to each other, we call diagonal. If each side is equal, we just call this a regular polygon. Then we learn to calculate the sum of interior angles of polygon. That's equals n minus 2 parentheses times 180 degrees. Then you can say the number of sides. Here we did list triangle, 3 sides. Each angle, if it's a regular triangle, that means it's an equilateral triangle. Each angle that's equal 60 degrees. And when you extended that interior angle, the exterior angle will be 120 degrees. Okay, then you have 3 exterior angles that will give you 360 degrees. Then for quadrilateral, we have 4 sides. If it's a regular quadrilateral, that's actually a square, right? Each angle equals 90 degrees. Then if you extended each interior angle, you got each exterior angle that's equals 90 degrees. Then 4 exterior angle also give you 360 degrees. For pentagon, they have 5 sides. Each interior angle that's 108 degrees. Then each exterior angle that's 72 degrees. 5 of that give you 360 degrees. Say for the hexagon, we have 6 sides. Each interior angle equals 120 degrees. Then each exterior angle will equal 60 degrees. We have 6 of this exterior angle that will give us 360 degrees. For octagon, we have 8 sides. Each angle equals 135 degrees. Then each exterior angle will equal 45 degrees. 45 times 8 also give you 360 degrees. Okay, Pentagon, that's 9 sides. Each angle equals 140 degrees. That's in interior angles. For exterior angles, if you extend this one, you got 40 degrees. 40 times 9, you got 360 degrees. For octagon, you have 10 sides. Each interior angle will equals 144 degrees. And each exterior angle will equal 36 degrees. 36 times 10, that's 360 degrees again. For dudecagon, they'll have 12 sides. each side, each interior angle equals 150 degrees. And each exterior angle will be 30 degrees. 30 times 100 times 12. That's also equals 360 degrees. So then here you can see one more time, all the sum of the exterior angle of any hexagon give you 360 degrees, right? And sum of interior angles, that's you need to use the formula 180 times parentheses n minus 2. Okay, so then we finished this section. Your homework, you need to finish the exercise problem behind the section 9.4 and also these review problems. And if you have interest, you can also do the challenge problems. Now let's go to chapter 10. Chapter 10, we will learn the geometric equalities. This one, first, let's consider the sides and the angles of a triangle again. Triangle it's very simple, but it has a lot of series here. Okay, so now let's see. First example. This one, they said if you draw a few triangles, label each triangle ABC and compare the order of the length AB, BC, and AC from the shortest to the longest to the order of the measure of the angles, angle A, angle B, and angle C. Make a guess about how the order of the length of the side is related to the order of the measure of the angle in a triangle. Try to prove your guess always works before continue this section. Don't forget, you have to consider acute, right, and obtuse triangles. So that means here they encourage you to draw a acute triangle, draw a right triangle, okay, and draw a obtuse triangles. Then suppose here you mark this one's A, B, C. This one A, B, C. This one suppose A prime, B prime, C prime. This one's A double prime, B double prime, and C double prime. Okay, this one's the right angle. This one that's greater than 90 degrees. This one, all these three angles less than 90 degrees. So then they said, if you start from the shortest side, suppose AB that's shortest, then suppose BC that's second one, and AC is second one, BC that's longest. Then they encourage you measure the angles. Then you can guess the angles also follow the same order. The shortest side that corresponding to the smallest angle. The longest side corresponding to the largest angle. Then the middle sides corresponding to the angle also between these two angles. That's always true. Okay, whatever kind of triangle, acute, right, obtuse, always true. You say this one's 90 degrees. Definitely these two angles less than 90 degrees. Then you can say corresponding to this right angle, that's A prime, C prime. This one's hypotenuse. That's longest side in this right triangle, right? Then this angle looks like greater than this one, right? So then you can say this leg, A prime, B prime is longer than B prime, C prime. Okay? In this obtuse triangle, you can say this angle is greater than 90 degrees. Then B double prime and C double prime, this one is the longest side in this triangle. Then you can say this angle looks greater than this one. Then this side will greater than this one. This is always true. Okay, so time is up. We can stop here. Next time we'll continue from the second problem. So see you next time. Bye.